Okay, hello, welcome back for another week. Okay, lab exam week. At least I assume we'll have a lab exam. Still looking for some more invigilators. Okay, I'm sure we'll get that sorted out by the end. That's actually turns out to be one of the toughest things is to get people in. So if you think it's hard for you to come in on a Saturday, yeah, trust me, it's hard for everybody. So anyways, we'll have that set up. Please check. I'll make sure it gets posted around to a couple of spots, the schedule. Just check on Friday. I'll probably have it up before then. Exactly which room to go to. Don't expect it'll be the same room as last time. Okay, just check. Somebody will be there with a list of rooms in case you don't check, but it's easier if you already know so you don't have to ask anybody. All right, so traditionally what I have done is I spend the entire week doing kind of reviews of usually previous lab exams. And a couple of semesters ago I said, well, why don't we just give out the lab exam questions from previous semesters? Because I know a few people have them already because I've heard that, yeah, people are collecting them. They have a library. I might as well just give them directly because it's fair. I mean, I'm never going to use the same questions ever again. Okay, so even if you go and memorize everything that's in here, trust me, what you will end up seeing, you'll see another 5 new ones that have never existed before. And then a week later for the deferred exam, you'll find another 5. Next semester, there will be 5 new ones. Okay. However, that doesn't mean that these are not worthwhile actually doing. But what you want to do is you want to work through the problems as if you've never seen them before. So even if you have done them a couple of times already, go at it and take the approach of, okay, I'm going to pretend I'm explaining this to somebody even if they're not there, and this is how we're going to solve it. Okay, and that's my plan for the day. Because, I mean, to be honest, they won't take very long to solve. I mean, I could blast through these things probably in about 10 minutes, but obviously that's not going to be helpful for you. And I've made the comment before, seeing the answer is not the same thing, and I think you've discovered that. Seeing the answer is absolutely not at all the same thing as actually being able to work out an answer yourself. And I know quite often I get complaints of students saying, yeah, it's so hard, I can work through these, but when I get into a test I have and unfortunately it might be because you haven't quite worked through the process, and you have to do a lot of this stuff. Anyway, so what I'm going to do today is I'm going to work through as many problems as I can out of here. Well, okay, I'll work through one set, and then maybe I'll go to the AI prompt. If I don't get through everything, that's fine. By the end of the week, I'll do at least the 5 questions from last semester and at least one AI prompt generated thing, because, I mean, that's great fun. Talk about put yourself on the spot. You type it into ChatGPT, say, give me a question, and then I have to solve it. Okay, but in any case, I will walk you through the process. So that's really the whole idea is like, okay, look, how is the process? It's never what's the answer, it's what's the process. And I'm hoping that that's what people are slowly learning in this course. All right, but in any case, I will do this today, and I will repeat not the same questions, but the same idea next time. And as I say, we'll at least have one thing done. All right. It doesn't work out very well for me, so give me a second because I've got a copy of this open up over here in, where did it go? Give me a second because it has vanished. Let's see. I find copying and pasting from that document in D2L is a little bit strange. All right, hopefully this ends up working out better for us. All right, so as I said, this is basically a sample document containing everything that I get my fingers on that made sense. Okay, because there was a few questions, it really didn't make much sense. Like, for example, if you take a look at, say, fall 2023, and then you realize that, wait a minute, that was it, there was only one question? That's not fair, now we have 5. Yeah, okay, so I'll explain why. This was kind of an oddball case. It used to be that in INFSC 1101, they hardly did anything. Like, they would cover Python in the last week. So what we were doing in 1201 was we were covering everything. We were covering if statements, we were covering variables, we were covering loops, we were doing everything, including functions, for the first time. And by the time you get around to the lab exam, there wasn't much you could do. Okay, so I got rid of the questions that didn't make any sense because I didn't want you to look at it and say, oh, look, I just need to have an if statement. That's not going to show up this way. All right, the things that will probably be a lot more sensible are going to be towards the end because this is kind of the direction now. It's closer to the types of things that we actually do ask. All right, so winter 2025. Well, I guess we have a semester after that. So let me go forward. Let's see. Here we go. This is the fall 2025. So that was our most recent semester. So what I will do is I will work on these problems. And yes, there's one more set that comes afterwards. I thought I would include them as well. It's the deferred exams. That's for people who end up not being able to write the main exam. They end up having to do a deferred exam like a little bit later. So that's actually kind of an important thing. What happens if I'm out sick? I don't recommend being sick and doing the deferred exam. However, if something does happen, the deferred exam will be available. Chances are it will be the very next week. And no, there won't be a case of, oh, well, maybe he'll use the final exam grade. No, he won't. If you miss this exam and you miss the deferred exam, it will be 0. Okay, regardless of whatever happens. So just make sure to show up to the exam. It's better to get it over with than to even put it off a week later. All right, so here we go. As I say, we'll walk through this one question at a time. I will walk you through the process. Okay, so this is my solution process for this. And as what I said during the midterm, I saw that students were actually doing this, so that's good. So we're going to write a function called past assessments, okay? So it's either past, P-A-S-S-E-D, that means maybe we're going to count how many. It takes a list containing alternating names, assessment names and grades, and a passing mark. Ooh, okay, and a passing mark. Ooh, so that one's got actually a little bit of a weirdness because, oh, sorry, that's the name of the function. Okay, perfect. Okay, we got this right now. So the first piece is a piece called data. Okay, and it's going to contain a bunch of alternating assessment names and grades. We'll take a look at the one example. So here we go. This is the first parameter that gets put in. Sorry, it's just one extra item. And you can see what we've got. We have quiz 1, 45, assignment 1, 78, quiz 2, 60, assignment 2, 49. So, of course, the first thing is you'll have to understand what's going on. So, yes, that's the name of the assessment, and that's the grade the student got. So in other words, the student got a 45 in quiz 1, a 78 in assignment 1, a 60 on quiz 2, and a 49 in assignment 2. Okay, they didn't seem to do very well. There's a second parameter, sorry, wrapped around. Sometimes this happens as I extract things out of D2L. And the pass mark for this particular course is 60. Okay, because different courses might have a different pass mark. All right, perfect. So, and a passing mark. All right, if you ever see something like this, that is an HTML code for a space. So sorry, sometimes it happens. It's because things are stored in D2L and HTML format, and sometimes if I just quickly copy and paste stuff out, these things show up. So sorry, it shouldn't be there. Just pretend you don't see it. All right, the function must return a list of assessment names that grades greater than or equal to the passing mark. It should say whose grades are greater than or equal to the passing mark. Okay, so in other words, if we take a look at the example right here, if the pass mark is 60, should quiz 1 be part of it? And the answer is no, because it's a 45. Should the assignment 1 be part of it? Yes, because it's a 78. Quiz 2 should also be included because it's a 60, but assignment 2 shouldn't. Okay, and business program here, and health science. Yeah, health science got these weird requirements that the pass mark is a 70. Okay, now I'll ask you a very important thing because these are questions that I keep getting asked, even though it doesn't exactly say in the text. If somebody gets a 60 exactly, do you pass? Yeah, okay, so in other words, it's an inclusive thing. You can always ask for clarification, but I mean, in this case, yeah, we did make it very, very clear that it was greater than or equal to in the examples. But if it isn't clear, yeah, you can ask. Okay, somebody should answer you and not tell you to go away. All right, if somebody doesn't pass anything, we're going to get ourselves an empty list. Okay, and of course, if there's any other issues, like you pass in an empty list, or if you're missing a grade item for the last ones, midterm 75 final, whoops, we forgot to put it, then in this particular case, we said we're going to return an empty list. Okay, so we'll just simply say, yeah, no good. All right, well, let's go for it. Okay, so go for what? Well, my suggestion in life is do not copy and paste the entire input program to try it up front. Pick the first one. Generally, the first one is usually what I would put in as some kind of a standard case. Okay, so it's not like the most strange case. I usually try to leave something fairly simple for the first one. Okay, I can't quite see it. Okay, no problem. I'll just press enter here, and I'll press enter here. And okay, I'll press enter here, and maybe I'll bring this back. Okay, so the formatting of these things, of course, isn't a really big deal. Okay, and if it is, well, then we can fix it. I just need to be able to see it. Okay, so we're run. Okay, past assessments is not defined. Yeah, I start with this. Do you go and write the entire thing? Okay, now I saw a couple of semesters ago some students actually just go and type the entire thing right out front and basically solve the entire problem at once and then deal with syntax errors for some time. This is not actually the way to approach problems. Incremental. You see what I do. Incremental, okay? So that means start with something very, very simple. And if it means starting with an absolutely nothing, start by this. Okay, so past assessments. You see, we need to fix this one, so it does. Okay, here you go. All right, so we're partway there. At least we have a different error. The problem is that currently I'm not accepting any parameters, but instead I need to hand in 2 parameters. Let's see whether or not it told us what to call it. And the answer is yeah, we had some data and a pass mark. Okay, yeah, we can reuse those. There's always a question that shows up is what happens if I change the names of these variables? That's not a big deal, okay? No, of course they're not variables. What they are is they are parameters. All right, parameters, yeah, you change the name, we have no problem with that. However, do not change the order, do not change the meaning, but change the name. So if you want to call it something else like assessment list and passing grade, that's completely fine, but just don't change the order. Don't flip them around, because what will happen is the instructor will take a testing program, it will copy your function in, and basically it runs through a whole bunch of stuff. And the things that it will watch for is it will watch to find out, hey, did they remember to put a doc string in? So don't forget that. Yes, that is a coding guideline violation. It's not a big one, but I assume that you don't want to lose a mark for it. And it will also check to make sure that you are not using any global variables. Because remember, sometimes what ends up happening is you might have something out here, scores, with a bunch of data, and then inside the functions, if you're talking about scores, you're going to get into trouble for that one, okay? Because everything that we work with comes in as a parameter. All right, first thing that I always do, just print out the data, print out the pass mark. Make sure you can see what we've got. So here we go, here's the pass mark. If you don't have the data we're looking for, there's no reason to continue, because again, I've also seen students be stuck for a really long time because they've done something kind of silly, like maybe they accidentally hit one extra item here, and they're stuck on this problem. But now what they have is they don't have a simple function like what I've got, but they've got like 10 lines of code, because I don't know, they saw something across the aisle from where they're sitting, and they thought, yeah, I'll try to copy it. Don't copy from other people, solve your own problems, because you never know what problems they're having. Okay, and sometimes you just make a mistake like this. You want to debug problems. You want to debug a small problem. If you have the choice between fixing a small problem and a big problem, you always want to go for the small problems first, because it'll be much easier. All right, so good. I can see the data, so at least my function is working. It's returning something. Yeah, well, it's not returning anything right now, but at least everything is working. Okay, so what is it we're trying to do? Well, you see, I've got a bit of an issue. I've got a bunch of quiz names and a bunch of quiz grades in a format that I call interleave data. Now, this used to not show up in the labs, but I'm pretty sure this semester I actually included this into a labs, because it's something that sometimes we have to deal with. And that is, you see, this right here is a name, this is a grade, this is a name, this is a grade, this is a name, this is a grade, this is a name, this is a grade. Do you notice where all the names appear? Which positions? 0, 2, 4, 6, 8, 10, all the even numbers, and all the grades appear in the odd positions. Okay, good. So yes, you could set up a loop to go through for all the indexes, and wherever you see an odd index, you know you've got a grade, and where you have an even index, you got yourself a name. However, you know what, we can probably be a little bit, I don't want to call it lazier about this, but we got some really cool stuff built into Python called list slicing. And it's actually one of the things that you can use list slicing for. In fact, I'd say list slicing is good for 2 things. Picking out a sublist, You want the first n things or the last n things. It works really well. It's also really good for dealing with interleaved data, which is why I include it now as a lab exercise. You see, I've got a whole bunch of names. Okay, if I want just the names, what I could do is I could go to the data set and say, well, if I ask for this right here and print names, what am I doing? I'm saying give me everything in the list but every other item in the list. And you see what I've got? Now I've got a bunch of names. Okay, oh, and we also want some grades. Okay, so let's have a bunch of things called grades. Data at, ooh, well, obviously not this one. Okay, here, I'll print this one first. Some grades. Okay, if I run this right now, of course, it'll say the same thing twice. But the thing is that I want every other item, but I don't want to start at the beginning. I want to start by one off from the beginning. All right, there we go. So now what I've done is I managed to separate these two. Once you have them separated, now you might be able to process these things. Is it possible to do this without separating? Yeah, it's certainly fine. And if you say, yeah, I prefer the approach with the even odd indexes, yes, it's completely fine. I will leave that as another exercise that you can try to see as a slightly different approach. I tend to like this one. All right, now by having these separated, well, now I can set up a loop to go through them. But the thing is that this is a slightly more challenging problem than iterating through a single list of data. This is now iterating what I call parallel iteration, where you're going through two at a time. There's no easy way out of this. What you're going to need is you're going to need some kind of a for index in range length of names. Okay, so here's what we're going to do. Is I'm going to row through these things. If I print out index, just to show you what I've got, I'm not going to print these, say, okay, I'll still leave these out. So notice that it goes through 0, 1, 2, and 3. Well, notice that 0, 1, 2, and 3, 0, 1, 2, and 3. Okay, perfect. That's exactly what I want. In other words, what I really want to do is I want to be able to look at this, and I want to be able to look at this at the same time. All right, so let's use this. Instead of printing off the index, what if I print the names at the index and the grades at the index? Okay, let me get rid of those. Okay, see what I've got now is I managed to separate them by putting them both together onto the same line. So one statement, one if statement, I have access to the thing that I need to check, which is the grades, and I have access to the thing, which is the names, which is the thing that I want. Okay, so again, printing. Yeah, you don't try to write everything and then maybe work out what's going on. Just print it. Just print it. What do we have? Now, the thing is, I'm not interested in printing all this information. I'm only interested in the ones that are higher than the passing mark. So let's introduce a filter. Here we go. If the grades at the index happens to be bigger than or equal to the pass mark, my finger down here. Here we go. Yeah, you see, now those are the two things that I need. Oh, sorry, I don't need the 78 and the 60. I'm just interested in these items right here. There we go, quiz assignment 1 and quiz 2, perfect. But of course I don't want to print them. What do I want to do with them? I want to send them back as a list. Yeah, okay, and we've learned how to deal with this a whole pile of times. To send something back, if you have a bunch of data, you're trying to filter things into a list, then what you do is you start with some kind of an empty list. Instead of printing them, you add it to the collection. So in this case, it happens to be an append, and we will stick this at the end. This will be, names at index. Okay, and then the final thing, return the result. Okay, excellent. So there we go. Now, usually what I will say in exercise like this, I don't know whether or not it says it in the question. Sometimes I miss this. Usually I would say the order is not important. Okay, so in other words, if your solution produces quiz 2 and assignment 1, yeah, I would take that. Okay, and again, you can also confirm with that. Usually I try to include that, unless I say very specifically it has to be in this order. Then usually it can be in any order, and hopefully if you have problems getting points for that, let me know. Especially unless it says it has to be in a particular order, that means you get to do whatever you want. All right, now we have a couple of things, of course, that we have to find out. Does it work? Okay, what if the pass mark for the course is 90? Okay, well, nobody would be happy, right? All right, but let's suppose the pass mark is or it's 90. How many people should pass, or how many assessments were passed? 0. All right, so it should be an empty list. Okay, excellent. That one's pretty easy. But I've got another condition in here that I also have to work with. Let me turn this back to 60. And it's this one right here. All right, you see, that's an issue. Okay, now that's an issue. I know that there's going to be another issue as well. We'll also talk about it. But this one is going to be an issue. And by the way, it was mentioned, and that is what happens if somebody gives the name of the assessment, but they don't give the grade? Okay, what do we do? Now, from a design philosophy, in general, for programming, you don't have to make these decisions here, but if you continue on doing programming in later courses, you might be expected to do this. The question becomes is, what do we do? Do we just have it show up as some kind of an error? Do we try to send back maybe just assignment 1 and forget the assignment 2? That depends on the philosophy of the person designing. Now, we were actually given the instructions, it must return an empty list. If I try running this right now, it blows up. Okay, and we better figure out why does it blow up. Okay, because if we don't understand why it blows up, we would be just guessing about what's happening. Okay, so, and this would be one of the test cases. So what could have possibly happened? All right, well, the way how to answer this is to basically start looking at data before it happens. Okay, we got ourselves a list out of range, or list index out of range. So what this means is that somebody tried to access a list position and it blew up. It was just too big. Now, unfortunately, it didn't tell me any of the other details. So you have the option of kind of looking and hoping you spot it. Not a very good idea. It will probably work here because it's not a really big problem, but we're talking in the middle of a test. I assume that you won't be like relaxing at this point. You'll be stressed about other things. And you know what, even for me, sometimes this happens. You get into a stressful situation, things look obvious to one person and it's not so obvious. Look, the way how you solve these problems, remember what I've been doing all along, I print an awful lot of stuff. Here, names, print, grades. I kind of recommend you leave the print statements around until you've got everything finished because you might have to put them back. All right, now take a look at the names and the grades. How many names do I have? 4. How many grades do I have? 3. Do you suppose that's the problem? And the answer is yeah, that's exactly the problem. Because what I'm doing is I'm going through all of the names. So 0, 1, 2, and 3. That's going to work for the names, but it's not going to work for the grades. That's the issue. Okay, so at this point here, if we detect that we have the wrong number, so if they're not the same number, this is the issue. So here you go. If the length of the names does not equal to the length of the grades, at this point, they want us to return an empty list and nothing else. Okay, so there you go. So that's a way out. All right, so finally that one looks after. At this point now you can clean up the print statements and you can put in a doc string, something appropriate. One statement would be fine. What does this do? It returns a list of the assessments that are equal to or larger than the pass mark. And then, of course, you should mention what the data format looks like, what the pass mark looks like. And yeah, maybe you can probably copy and paste a lot of the stuff that comes. But yes, we do want this, even though it sounds a little kind of silly because, yes, you are really implementing the same things that we're doing. All right, so there we go. Okay, first question. Yeah, it took a little bit long time. Yeah. Oh, 25 minutes is usually what I've set these things for. Okay, because it's 5 questions, 2 hours, 25 minutes. So that's, of course, with a lot of explanation about what I'm doing and why. Okay, but, okay, would I do it the same way if I was solving the problem myself without you being here? Yeah. The difference is I wouldn't be explaining it. Okay, but I would be doing exactly the same thing. Okay, let's move on to the next one. All right, next one up. Where did my list go? Here we go. So that's the first one. Oh, and you got some extra things you can try as well. Okay, so here we go, off to the next one. All right, question number 2. You're working in an accounting firm. Yes, I decided I would leave some stuff in for the banking fintech students. And after querying a ledger, you receive a list of tuples representing transactions. Okay, so, well, a list of tuples, very typical thing that we do. Each tuple contains the following. Now, I left something in here, and sometimes I will do this, but I better explain what they are. All right, so what did I do? I have a tuple contains a transaction type, an amount, and a date. But then what are these extra str floats and str? It's just to tell you what type it is. Okay, there's nothing funny. It's a convenient notation. It's not Python. It's just a notation to say, yeah, these are strings. The amount is a float, and the date is a string. That's all that it means. Okay, write a function that returns the following items as a tuple: the number of deposits, number of withdrawals. Okay, I'm not really a big fan of returning tuples, because my opinion in life is that a function should return one thing, not two things. But I guess maybe this was picked because we need to have a tuple, so return. It is a use of a tuple. I personally don't like it. I'd rather have something that counts the number of deposits and a different function that counts the number of withdrawals. It's probably a little bit easier. But in any case, yeah, it's going to be a number. So there's an example down here, and it says, okay, if we have these following transactions and you count these things up, yeah, there are 2 deposits, 2 withdrawals. Okay, it says ignore any other transaction types, and an empty list would obviously just return nothing. Okay, so let's steal this one, and let's go over and try it. Okay, good. I can see everything. You can indent that again if you want. Doesn't matter. All right, if we try running it right now, the count summary is not here. So def count summary. Okay, what does it take as a parameter? Let's see. What did we call it? We can steal the same amount or same things. Oh, it hasn't actually given a format this time. Ooh, okay. So what do you want to call this? Because this is being passed in as tx1. How about transactions? Yeah, okay. We'll call it transactions. You want to be, here we go, transactions. If you want to call it txn, yeah, I guess that would be fine. And for right now, we'll just return none. I just want to make sure that I've got the name of the function correct and the parameter passed in correctly. All right, so what do we got? We've got a list of tuples. Okay, what do we need to do? We need to count things. Okay, but guess what? You can't use count because you have to count one part of the tuple. So yeah, it's not going to be a simple one-liner. You're going to do a little bit more. All right, well, I've got a whole bunch of transactions. How many? Well, I don't really know, okay, but hey, I do have this thing called transactions, so let's go for it. For t in transactions, print t. It's my first attempt at it just to see what I got. Do I have the right data? Yeah, we've got it. Okay, now, here's the thing. This is kind of a big mixture of everything. It's deposits and withdrawals. Oh, but that means that I have 2 things I have to keep track of. I have 2 counts, and maybe that is the whole reason. So let's have this. We'll call it num deposits. I'll be a little bit lazy, num dep, and num WD for number of withdrawals is 0. Okay, so all that I have to do is to go through each transaction, and basically if it's a deposit, I increment 1 counter, and if it's a withdrawal, I increment the other counter. Okay, well, let's worry about the printing this or incrementing in a few minutes. What type is T right now? So I'm printing T. What type is it? Tuple. When you're iterating through a list of tuples, one of the easiest ways to deal with a list of tuples is to use tuple unpacking. You don't have to, but I find it very, very helpful. And remember, the way how tuple unpacking works is you pass in exactly the right number of things. So A, B, and C. What will happen is A will be the first item, B will be the second item, C will be the third item. Oh, but if I had to give a name instead of C for this, what is the third item in each tuple? A date. Okay, so let's use the word date. What's the second item? The amount is fine. And this one right here? Type. Okay, I probably shouldn't use type. Could I use it? I could. Should you use it? And the answer is not really. Okay, so how about this? How about TX type? Okay, yeah, sometimes we have to do things like this. All right, and if you want to call a transaction type, it's completely fine. So here you go. This is kind of the way I would normally iterate through a list of tuples. Oh, do you do this for iterating through a list of dictionaries? No, you do not want to iterate through a list of dictionaries using the same approach because you can't unpack a dictionary. Okay, or trust me, you don't want to try this. We'll take a look at it when we have one, but that's probably not a good idea. Tuples, it works really well. Okay, well, at this point right here, maybe we just want to do a couple of print statements. Okay, so here we go. Let's just say if tx type is equal to, well, one of the types is called a deposit, not depositor, and what we'll say is we'll say found a deposit. Okay, and we'll stick an if statement in here and say if tx type is equal to withdraw, and we'll talk about the other formats in a few seconds. Let's see, sorry. Yeah, you better match. Ooh, 1 or 2. Doesn't matter, but you have to match. Okay? All right, so print found a withdraw. Ooh, okay. So, withdrawal. Yeah, okay. You see why we print it, right? Because if we were just incrementing a counter, we'd say, how come it's not finding it? And again, I know it looks obvious, but when you're in the thick of things and you're under a lot of pressure because somebody is saying, look, you got 2 minutes more before you have to submit this thing, that could end up costing you, it's not going to cost you a lot, but it will cost you, and it can be very, very frustrating. Okay, there we go. So we found each of these things. Okay, perfect. Now, at this point right here, I'm going to ask a couple of questions. Okay, I have an if deposit, and then I have an if tx type is equal to withdrawal. Usually what I will get is I will have one student will say, should I do this? I will get another student to say as well, maybe I should just do this. Okay, now here's the problem with this one. Okay, here's the problem with this one. If it's not a deposit, it will automatically be counted as a withdrawal. Now, for the purposes of this exercise, it's completely fine. Well, sort of, but there was a small comment in here, and it says ignore any other transaction types. Okay, so unfortunately, if you were to use an if-else, it would actually count unknown things like maybe bank charge. That would be considered as a withdrawal, and it's not. I know it's coming out, but maybe something like this. Or here you go, salary. I mean, that would count as a withdrawal, and that's definitely not the case. Okay, so having that as a, sorry, one more. Here we go, deposit. Having that as an else, not a very good idea. Elif, yeah, it would work. Okay, it would work. There would be absolutely no problem because it's either this one or it's going to be the next one. You would have to do this if you wanted one extra item here at the end called, now that I remove that one, here we go. You could do this if you wanted invalid type listed, then you'd use an if-elif. Okay, but in this case, we are not asking for that. We're basically asking, is it one or is it the other? And they're completely different. All right, instead of found a deposit, okay, num dep goes up by 1. Num wd goes up by 1. And of course, at the end, you would print it first, because if you don't have them correct, then you don't know. All right, at this point right here, num dep, num wd, is the order important? Yes, it is very much important, because the program on the other side is expecting the number of deposits to come first. You can't switch the order around. If it was a dictionary, wouldn't matter. Okay, but because it's a tuple and tuples have orders, yeah, we have them. Okay, usual thing, docstring, and clean up any of the printing statement, and we're all good to go. All right, and then there's really, although there's one extra one in here with an empty transaction, you're not going to have problems with this one. Okay, there's nothing weird you have to deal with. But there was something in here for make sure that they're ignoring the unknown type. So you want to make sure it comes up as 1 and 1, not 1 and 2. All right, next one up. So how'd we do? Okay, that one's a little bit shorter, where I talk faster, maybe. All right, here we go. You're working as a project manager in an IT company and need to write a function to help you locate employees to work on various projects. All right, write a function called employees with skills. Okay, hopefully the employees have skills. You provide an employee list and a required skill, And the function takes a list of employees, blah, 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 blah. Sometimes it's easier, I completely admit, to go and look at the example. And feel free to go and scan the example first and then read the description. I always have to include a description because there might be special cases I have to list, so that's why the description is here. But if something doesn't make sense here, look at the example because it might actually give it away. But in any case, every employee has a name, a phone, and a set of skills. Ooh, there's a set. Yes, this is obviously some kind of a question I needed a set for. And it also takes a second parameter called required skill, which is a string of the skill being searched. So here's the idea. You have a whole bunch of employees. Some employees have certain skills and basically saying, okay, give me a list of everybody who has Python skills. Okay, and you get back a list of these things. The function returns a list of tuples. Oh, okay, well, I've already said before I don't like lists of tuples, but in any case, we're going to return a list of tuples where each of the tuples is the person's name and the phone number. Okay, maybe what we should do is take a look at this because maybe the example will make more sense. Okay, so we have a bunch of employees. Okay, good. So we have an employee called Alice, Bob, and Carol. Each employee has a name, a phone number, and, of course, the single curly brace indicates that we've got ourselves a set. And you can see that Alice knows both Python and Excel, Bob knows just Python, Carol knows Excel and SQL, and the idea is that, hey, I have a project coming, I need to know who can work on the project, and of course who I'm going to call. All right, so if I say, hey, I need out of the employees, I need everybody who knows how to deal with Python, I expect to get back a list of tuples. All right, again, is the order of the items in the list important? No. In fact, it says right here, the order of the tuples in the list does not matter, but the items in the tuples must remain in order. It must be the name, then the phone. Okay, so, and that kind of makes a lot of sense. Because you can end up with these issues where things will pop out of order. Usually, when I give you an example, you will get the same result because I always test using PyLock as well. Because that way I know that it's the same interpreter and there isn't like some kind of a weird thing that goes on. So normally you will get the same results, but if you do get something that's out of order, it's fine, but just make sure that it's always the name and the phone. So it's the tuple contents are always really important. All right, well, let's give it a shot and see how this works. So what's different between this one, say the last one that we just did? Well, instead of being a list of tuples like we had last time, it's a list of dictionaries. If I can ever highlight these the last items here. Okay, let's try again. There we go. Now we've got it. There we go. So we got a bunch of employees, and we're going to call employees with skills. No, skill. That's actually why I run this. Here we go. Employees with skill. All right, name of the parameters. Did I give a different name? Employee list and required skill. Employee list and required skill. Okay, and again, if you were to change the names of these, it'd be fine. Okay, it wouldn't be a big deal. You have to return at least something because otherwise your program won't run. Okay, first thing, make sure you got the name of the function correct, make sure you got the right number of parameters. If those are wrong, there's no reason to proceed. All right, second thing that I could do is I could print the employee list, I could print the required skill. Again, just to make sure that I've got them. I don't think I'll need to. All right, but next what we've got is we've got a whole bunch of employees. So let's go through the employee list, okay, and we'll print it. All right, so let's try a couple of things. All right, I don't know what else, we'll just call it X. Oh, we'll call it E for employee. Okay, in employee list, print E. Okay, there we go. So do we see all the employees? Yeah. Okay, excellent. All right, at this point right here, sometimes I will see students try to do this. So let's give it a shot. Name, phone, skills. Name, phone, skills. Is that helpful? No, it isn't. I've seen students be stuck on this because, of course, what they will start to do is they will start to put in questions like this. If phone is big, okay, let's just put it maybe this way. If the length of the skills is bigger than 1, then maybe you were doing something. Okay, you see, this also doesn't have a problem. Of course, it's not making any sense. Here we go. Let's see, run. Here we go. So same thing, because the length of the skills is bigger than, because skills is actually the word skills. It's not the actual value. Do you see why it's important to print things? Okay, print it before you start making decisions, because if you happen to be getting back something that's a little bit different, it's not going to work. Yeah, so if you try to use a for and you attempt to unpack a dictionary, you get the names of the fields, which is probably not what you want. Okay, so yes, this is the whole reason why you print these things. All right, here's what I really need to do. Okay, I'm just going to take off this thing. It's going to be called emp. No, not a return yet. Print emp. List of dictionaries, no choice. All right. If you really want to separate things out in the variables, no problem. How do you get the name of the employee? You go to the emp employee and you ask for the thing called name. Okay, you would probably get the phone number. Okay, I'll go with this and I'll ask for the thing called phone, and I will get the skills and emp skills square bracket. Here you go. That's pulling out the individual things, name, phone, skills. Okay, now I'm getting the data that I'm looking for and not the actual name of the dictionary. All right, at this point here, I can start to ask questions. Okay, am I interested in Alice? And the answer is yes, because Alice knows Python. Am I interested in Bob? The answer is yes, because he also knows Python. And am I interested in Carol? Not in this case, because Carol doesn't know Python. How can we make this decision? Okay, well, what I need to do is I would just need to find out, is the required skill, how do you know if a value is inside a set? Yeah, it's just in. So if it's in the skills, then we'll print it. Good. We're down. We've only got the 2 people now. I don't care about anybody else. These are the people that I want to provide. I need their name, I need their phone number, I don't need anything else, okay? Oh, and it's going to be sent back as a list. Well, we've done this before. Start with an empty list. Instead of printing things, result.append. Oh, what do we need to append this time? Yeah, two things. Now, this can be a little bit weird, so let's try it this way. Name and phone, because it kind of looks like a tuple, right? And all that I'm going to do at the very end is I'm going to print the result and then we'll return it. Unfortunately, this doesn't work because what it thinks you're trying to do is it looks like it's trying to append both a name and a phone onto the end of this list, and that's unfortunately not it. It's one of these weird places where if you want to turn this into a tuple, you actually need the second set of parentheses. All right, there you go. That's now the result. And of course, instead of returning none, I'm going to return the result, and I'll get rid of this. So there we go. A couple more things to clean up. Maybe my print statement. Here you go. Now we're down to everything. Okay. I don't think I'll expect any type of weird business, so I won't bother testing the others. I guess there would be the question. Okay, what if somebody is looking for that programming language, the Python non-none? Okay, how many people have that? Probably nothing. So what would you expect as a result? Probably an empty list. Okay, that seems pretty reasonable. Okay, but watch out, because maybe the statement says if there's nobody there, it's supposed to return none. And if it did, okay, it's not part of it, but here's what I would have to do. I would simply stick a question at the end. If the length of the result was equal to 0, then I would return none, if that's what I was asking for. That's not what I would normally do, but you never know what type of program you're getting or who's writing the programs. Okay, I would prefer this one. All right, okay, again, hey, no, also not too bad. Okay, congratulations. At this point, if you have done these questions, of course putting in the doc string each time, you will have made a 70% on this lab test. Okay, because that's the way it's being skewed, is that the first 3 questions are worth 70%, the last 3 questions are worth the 30%. So the idea behind the last 2 questions is the last 2 questions are supposed to be a little bit more challenging. Okay, sometimes they are, sometimes they're not. Sometimes you might just notice and say, oh, that's actually not a difficult thing, because you happen to get the idea that, oh, it's just one of these. Okay, and sometimes this happens, and that's great. However, the one thing that does happen in the last couple of questions is the person grading you will show no mercy. Oh, what does that mean? It means if it doesn't work, don't expect to get very much. Okay, like you might not get anything, even if you've got really small mistakes in it. A little tiny thing, okay, you know what? Maybe they would allow it. Do you think anybody's going to feel any sorry for this one? And the answer is no, because that's a syntax error. Everybody should be able to find it. Okay. That one's a little bit more subtle, but again, you've got an interpreter. You know if it works or doesn't work. So again, they may or may not. Maybe they'll feel sorry and give something. They're not supposed to, but they might. Okay, so just to let you know, the last 2 questions, as I say, very little mercy on these. All right, but let's go take a look and see. Maybe it's really easy, maybe it's really tough, maybe it's just a little bit tricky. Okay, so here we go. Your task is to add some frequent user points to a local food delivery app. So basically, think of like Snoo or Talabat. Basically, you have a bunch of orders, and for every time you order something, you get a certain number of points. All right, and you are given a dictionary of users and their orders. Okay, so what this means, okay, first of all, we have to understand how many users do we have? Looks like 3 users. Okay, Mohammed, how many times does Mohammed order? 4 times, okay. There we go. And they're obviously going to get some points for this. There's some rules about the points, okay? Every time that you place an order, you get 1 point. But, of course, you get more points for more money that you spend. So if your total is 10 rial or less, less than 10 rial, you get 5 points. If it's between 10 and, but less than 20, so 10 through 19, well, actually less than 20, because it could be 19.99, because they're all floats. We would clarify that, because I remember getting asked that question last time. Then it would be 10 points, and if the price is 20 or more, you get 15 points. Okay, so write a function called compute user points. You give a bunch of orders, and it tells you how many points you should get. But to make it a little bit more interesting, it isn't per person, it was for everybody. And that was the thing to make it a little bit more interesting. If it had been just a single user, okay, I mean, that's got a certain level of difficulty, but the fact that we're going to produce an output for every user, that's where the little extra piece of, well, the difficulty increases. All right, well, let's just go for it and see what we can come up with. Okay, I'll even take the example so we don't need to come back and check it, and I hope there's no mistakes in it, but in case, here we go. All right, so here we go. We got a bunch of orders and compute the user points. Okay, well, yeah, start 1 piece at a time. Def, here we go. Compute user points. Orders. Okay, good enough. We'll use orders this time. I'll just return a none, make sure that I run. Okay, so it's no problem. Now, what we need to do is we need to compute for each user. Ooh. All right, well, let's just start by seeing all of the information. Okay, and I can even show you kind of a cool little trick sometimes that I end up using when I'm dealing with something like this. All right, let's start off by simply printing the names of the people, because obviously the names of the people are kind of important because I need to repeat this. So, okay, I've got this orders. Orders is now a dictionary. Oh, it's a very difficult thing. It's a dictionary, and inside the dictionary, the key is a string, and the value is a list. Oh, and inside the list is a bunch of tuples. So you can see how I'm starting to stack multiple things together. Yes, things become more difficult, but things become a lot more realistic. If we think about, say, the grade name followed by the grade, the assessment name followed by the grade, and so on, that's not really a realistic situation, but this certainly is. All right, but in any case, let's just start by seeing what we've got. Let's print it. And, you know, a lot of things, yeah, you're probably going to iterate through things. Not always, but Let's start off with for X, because I'm just not sure. For X in orders, print X, and I'm just going to ask you the question, what do we see? Yeah, names only, yeah. Ah, okay, good. So this would be just the names. Now, that's important, okay? Somebody has suggested, okay, maybe we could use a dot values. If I show you the dot values, it gives you, of course, the orders. But what's missing from this is the names, because remember, what I need to put this together, I need both the name and I need the order information, and of course to deal with both of them. Items, okay. There we go, so we have both of them. And of course that always returns as a tuple. Iterating through a bunch of tuples, tuple unpacking really helps. That's the name, and this would be the order. I'm going to call it the order list. Okay, but if you want to call it just order, I wouldn't call it order. I wouldn't call it O. Okay, if you call it the word order, that could be very confusing, because is it one order? It isn't. It isn't one order. It's a bunch of orders. If you want to call it orders, okay, I could live with that. Okay, that would be fine, because that is at least a bunch of extra things. Would I call it just O? Probably it's going to make your program more difficult. I wouldn't take marks for it, but it's going to make your program more difficult. I would like to call it an order list, because that's really what it is. So here we go, a name and an order list. All right, good. So we're going through and we're dealing with all of them. Now, what's the second thing we need to do? Well, now we have to go through and you have to figure out how to calculate these, how many orders I've got. Now, there's a few different ways how I can deal with this. But the problem is, my output right now is so confusing, because I've got names and now I've got this whole pile of orders. Here's a trick sometimes that I use when I'm dealing with something like this. I stick a break. It's not permanent, just temporary. How many times is my loop going to happen? One. Good. So in other words, I'm just isolating one person. Okay? And then once I have it working for one person, I'll just undo it and we'll see everything. Okay, but we'll start with just one. All right, so that's the data. Well, what I'm going to need to do is, well, I've now got an order list. Okay, well, I'm going to have to go through and I'm going to have to figure out how many orders the person has and how many are less than 10, how many are between 10 and 20, how many are 20 and above. All right, well, here's what I think I might do. For X, okay, just X for right now. For X in order list, print X. There you go. Those are the individual items. Okay, here we go. We'll stick a print statement just so I make it very, very clear. Here you go. All right, so the stuff below the line, yeah, those are, okay, so we need to come up with the name of these things. What are those? That's an order, okay. But they're tuples. Okay, they're tuples. When you're iterating through a list of tuples, tuple unpacking is really useful. Okay, all right. What's the first part of the tuple? What's it? Yeah, the name, okay. But it's not the name because that's the name of the person. Okay, I'll call it a restaurant. Okay, yeah, restaurant is really good. Okay, or maybe a place you're buying it from. Okay, restaurant works really well. It's at least some food. All right, and what's the second one? The amount. Okay, perfect. So what I will do is I'm just going to print all the amounts, because once you have all the amounts, I have all the information that I need. Okay, but of course it's only for one person. All right, so what I need to do is I need to come up with a total number of points. So here we go. You see, I'm going to start off with 0 points. I'm going to add 1 point. Why? Because for every time that there's something in the list, I get 1 point. Then there's some extra stuff. If the amount, okay, so now we have to go back to our table. What does it say? It says if the amount is less than 10, it's 5 points. If the amount is between, okay, then it's this, otherwise it's this. Okay, so let's do it this way. If the amount is less than 10, points goes up by 5. Okay. Elif, the amount is bigger than, what do we got here? Bigger than or equal to 20. How much does it go up by? Bigger than or equal to 20. 15 points. Okay, 15 points. And then, otherwise, if it's in the middle, 10. Why did I do it this way? Why did I do Because if I put the other one, I'd have to say L if amount is bigger than or equal to 10 and amount is less than 20. So I thought I'd just avoid an and. Okay? It works in this case. All right, and so that's the amount, and we're not interested in the amount, but what I'd be interested in here is printing out the points afterwards. Okay, 49. Oh, but remember, that's for the first user. All right, excellent. So if I remove the break, okay, maybe what I should do is, oh, I know, the name of the user and the points. Sorry, it's called name. That's what I called it up there. There you go. So name and amount. Perfect. All right, let's get rid of the break. So Mohammed 49, Fatima 17, Nasser 33. And yes, there's always going to be one, or hopefully there's always one worked example, and the example is correct. I do my best to make sure I don't lie on these ones. Sometimes I do in the labs, but never on a test. Not on purpose. Okay, so yeah, that's the expected, or sorry, we've got the right data. The thing is, we now need to do something with this data to put it into the right form because we're supposed to return a dictionary with this information. Yeah.
On line 7, why are we adding 1 point?
Oh, why are we adding 1 point? Take a look at the first bullet point. Each order gives 1 point. That's why. Because that way, if somebody orders like 1,000,000 1 real things, they will still get 1,000,000 points. Okay, plus the extra 5. Yeah, I know there's different ways how it can be done. In fact, what you could do is you could remove that line, and instead of saying +5 here, you could say +6. And instead of +15, you could say +16, and instead of +10, you could put +11. It would also work. Okay, it would give you the same. It would give you the same thing. I believe it's one of these things where I started with something and then changed it to something slightly different. Yeah.
Why don't we initialize the points counter?
Oh, okay. There's another possibility. Oh, if we initialize the points counter to 1, we might have an issue because what happens if the user has no orders? Okay, that might be a reason why I wouldn't initialize to 1. As long as you have 1, yeah, it would be okay. Another thing you could do is you could initialize it to be the length of the order list. That would give you 1 point for every transaction. And then you could go and give the extras. Many, many different ways. Okay, so initialize to 1, maybe not. Initialize to the length, yeah, that would also work. Okay, but of course the really important, oh, sure. Yes, so. No, you could add the 1 here because this is a non-conditional. This would always happen every time. Okay, it would work in this case. Okay, let's turn it into the correct output. Okay, well, we've kind of done stuff like this before. It's a dictionary. Yeah, remember, that's not a set. That's a dictionary. Okay, what are we going to do? Well, instead of printing it, we're just going to take and we're going to build up a dictionary where you take the name and you set it equal to the number of points, and at the very end, you're going to return the result. So there you go. There's the final output. A little bit of cleanup to clear up the print statements, add a doc string, and you're pretty good. Okay, so what do you think? Was that more challenging than the first 3? Yeah, because it involved a couple of extra things. And yes, as you start to build up these nested structures, something inside of something, yeah, this is where things start to become more complicated. I try my best to avoid ever sticking those in the first 3 questions. If something does show up in the first 3 questions, usually it's because there's an easy way to solve it where you don't have to do a second iteration. But yes, this ends up happening. So we talked about nested lists at one point. And I said, I don't really like nested lists because we don't have them very often. But to process them, you needed 2 loops. And the same is kind of true, at least in this case. But I think the next question might have something a little bit different. How are we doing? Oh, okay. I guess we will finish up this one, and then we'll hit the end. All right. Question number 5. You're analyzing an inventory price data for multiple stores. Each item in the inventory maps to a dictionary of store names and prices. Okay, not too bad. Okay, so laptops are available in store A, store B, and store C, and the prices are $950, $970, and $940. Okay, that's pretty straightforward. The first approach of this was I really wanted just a price range because I wanted to know, okay, how far does the price range change? All right, so what's the highest price in here? 970. What's the lowest price? What do we got? 940. What's the difference between those two? Yeah, 30. Okay, there you go. There's the that's the price range between two items. All right. However, this particular function also included some kind of a cap that said the price range is defined as the difference between the highest and the lowest price. The cap is the maximum difference for each of the items across all the scores. If the price range ever exceeds the cap, then the range should be set to cap. Okay, now we better take a look at this. Oh, but it's not doing it for just one item. It's doing it for a whole bunch of items. Ooh, okay, so that's a bit unfortunate. All right, but let's take a look at this to see if we make some sense out of it. All right, so unfortunately my question changed just a little tiny bit. Okay, so, or sorry, my sample. All right, let's do it again. What's the high, here, let's get a calculator. Okay, and I want to just look at, say, the laptop. Okay, so what's the cheapest laptop? $940. How much is the most expensive laptop? Okay, 1,020 minus 940. What's the difference between those? It's 80. Okay, there you go. So we expect to see 80 here, but instead we see 50. Why do we see 50? Well, because we said we're going to limit this. Okay, that's all. It's just some kind of a capped range. All right, let's try the next one. Let's try a tablet. What's the most expensive tablet? 480. And the cheapest? 450. That's pretty reasonable. All right, 30. That one makes sense. Okay, and the mouse. What's the most expensive mouse? 25. What's the cheapest? 22. All right, and it comes back as 3. That one makes sense. So the idea was that, yes, if you get these really big differences, then you cap it. Okay, it was one extra condition. Maybe it's not entirely a really good real-life example, but this is what I came up with. Okay, so here we go. And of course, we need to spit these things out in the form of a dictionary. Actually, you know, it's not that much different than the exercise we just did. We have a dictionary, and inside the dictionary, on the right-hand side, we have a dictionary this time, rather than a list of tuples. Okay, we have a dictionary. So it's a dictionary inside a dictionary. Okay, that's fine. And we were returning a dictionary. But of course, just like what we did last time, we're going to start by just printing whatever it is we've got. So we'll take this one, and we'll drop it back over to here. Okay, here we go, and as usual, we'll start with def compute capped price ranges. Oh, what a horrible name. Okay, whoever wrote this should not have written it this way. Inventory, okay, INV data and limit is what I'm going to use, and I'm going to return none. How come I didn't use the word inventory? Just in case I misspelt it. Okay, because I've seen students do that. You accidentally misspell something, and then now you're using a global variable. All right, it's just to make sure that, yes, they are separate things. Okay, compute capped price ranges. Okay, compute capped print ranges. Okay, this is why we do this. Okay, what do we need to do? Well, we're going to have to go through each of the inventory items. Okay. And yeah, it's never a single line, by the way. Okay, for x in inv data, print x, what do I see? The whole thing? Just the keys. Yeah, and this is why we print it. Okay, all right. Now, that is obviously important, but we're going to need more because we're going to need this. Plus, we're also going to need all of that data. So what are we going to change this to? Yeah, and you're gonna find that most of the time if you're iterating through dictionaries, you probably need the items. Where this way you have the key and the values. All right, so I see all the information that's required. I'm gonna make my program a little bit easier, just the same as I did last time. Now at least I only have one, okay? Because if you can't do it for one, guess what? You can't do it for 1,000 of them. Okay, and yeah, I do this whenever I'm writing stuff. If I've got a process of 1,000 students because I'm doing something, I stick a break because I just want to see one. Because if it doesn't work for one, well, it's not going to work for 1,000,000 of them because it's pretty easy to get rid of the break afterwards. All right, so one break inside the loop. Okay, let's give these things better names. X is not very good. Oh, this is a tuple unpacking. Okay, so this would be the item name, just so we've got something different, or product. Okay, product would work. Okay, we'll call it product. Okay, that's the name like laptop. Now, what is the next thing called? Prices? Okay, prices. Yeah. Prices. Okay, that's pretty reasonable. Okay, product and prices, just to make sure we've got it. Okay, the product, what type is product? That's easy. What type? Yeah, it's a string. Okay, and what type is prices? It's a dictionary. Okay. Oh, does this mean I have to go through and iterate through the dictionaries once again?
Yeah.
No. Yeah, you have to think about this a little bit different. You see, this is not really prices. This is price details. Price details. Or, let's see, store prices. Store prices would actually work even better. Store prices. Steal this one, steal this one. All right, you see, those are the store prices. It contains both the stores and the prices. Hopefully you remember that one. Prices. Spelled correctly. Here you go. All right. So what do we got? Prices. Sorry, I meant to type product and prices. Product and prices. Okay, good. Now, what type is prices? Actually, it's a dictionary values. It's a special type. I know that we cover this in the lab. Okay, it is one of those funny things, but it probably happened while you were online and everybody was asleep. Okay, that's fine. All right, but in any case, what does it kind of look like, however, inside? Kind of looks like a list, doesn't it? Yeah, and that's a reminder. This actually is kind of like a list. And if you don't want to have a dictionary values, you can actually convert the entire thing to an actual list by just casting it. Okay, and that's it. So you can just ask for the values and turn it into a list. Now you've got it as a list. And the reason why this might be really interesting is because how would I find the lowest value in the prices? Yeah, just use min. Okay, here we go, prices. And how would you find the highest price? Okay, there you go, prices. And how would you calculate the range? Whoops, should I use range? Probably not. Let's call it a price range. All right, how do you find the range? It's the highest minus the lowest. And if somebody's asking, do I really need to write all these variables? The answer is no, you don't. No, I mean, you could put the max price and yeah, it would work fine. We'll have to try a couple of things. Oh, and what do I do if the price range is bigger than the limit? You set the price range is equal to the limit. That's it. All right, so here we go in the price range. Okay, sorry, price range. And feel free to print these things out as print price range. Okay, that's what I get for trying to talk at the same time. Okay, here we go. So laptop is 50. All right, well, it'll work for the first one. If I just remove the break, tablet is 30 and mouse is 3, yeah. Yeah, this is what we're looking for. If I were to ask for a really, really big range like 500, then it'll give me the real ranges. And if I were to bring it down to something really low like 10, it would lie about the first things. All right, so that's fine. That's what we're looking for. However, of course, what I need to do is I need to now package this up into a dictionary. Oh, We just did that. It's exactly the same thing. Here we go. Result is an empty dictionary. Now, it's not always this easy. Okay, just keep that in mind. It's not always this easy. The result, given the name of the product, is equal to the price range, and of course, we will return that at the end as the result. There we go. And it's 80 because I changed the number to 500. Okay, so there we go. Now, got a couple of things that I have to deal with. Okay, and that is okay, what if there's no tablets? They're not available. There's no price whatsoever because they're simply not available. What we'll do, now I don't know whether or not there was anything in here. And by the way, okay, do I want to say something like this? Let's see. Prices always have positive numbers. Okay, that's been given. Each item has at least one store. Okay, so in other words, could I trick you and try this as a test case and say, look, you didn't handle it? And the answer is no, I couldn't do it. And you'd have your right to say, no, that's an unfair test. You have to give me the marks. Okay. Let's try to decide what we should do with this because, well, we got like 2 minutes, so let's try to figure this out. What should we do in this case? Your choice.
Default values?
A default value? Okay, that's one. Maybe just ignore it altogether. Okay, so in other words, I wouldn't see tablet in the output. Okay, let's just handle this one. If I try running this right now, it fails miserably, and I'm going to ask the question, why? The answer's there, but you have to understand why. And it isn't because this was a question, because it might be something that happens to you in a different context. Min arg is an empty sequence.
Because when we combine the
Okay, first of all, which line did it happen on?
Line 5.
Or line 20?
No.
Well, I see line 20 listed there.
That was not.
Yeah, okay, good. You're understanding how to read a call stack. Okay, excellent. On line 20, we called a function called compute cap price range, and on line number 5. Okay, if you have absolutely no idea what's going on, what you do is you go and replace line 5 with a print and figure out what's happening. Print the prices. That's the only thing I'm looking at. All right, does it make it clear now why it's not working? Because if you ask for the minimum of an empty list, there isn't anything there. All right, so if we really want this, what we're going to have to do is I'd have to put a question to ask. If the length of prices is equal to 0, you need to do something. Otherwise, you can do this. Okay, there everything else. Now, that's a very interesting thing, what I just heard. Continue. Because what does it do? Remember, it goes back up to the top of the loop and it keeps on going. It ignores the min, the max, the price range. All of that stuff is now gone. Yeah, so that actually works really well. Okay, and that's a really good solution to this one. Okay, this is the reason why we have these things called continue. If you don't like it, it's no problem. You say if length of prices is bigger than 0, do all this. Otherwise, well, do nothing. Okay, so it's entirely up to you. Okay, so there you go. Again, pass this in. So interestingly enough, if I ignore this problem right here, okay, so here's the eventual solution. Assuming. Okay, there you go. Has no attribute called values. Oh, sorry, colon, a finger slipped. There you go. All right, I don't care about what the number, the price range is 0, it doesn't vary. Okay, was it more difficult than the previous one? In some ways, not really, because you didn't need to have a second loop. But you could have solved it using a loop. But if you happen to know that the dot values return something that looks like a list and you can cast it into a list, then it ended up saving us actually quite a bit of time. Okay. All right, so there we go. And that basically burned all of my time. So what I'm going to do is on Wednesday, I will pull out the deferred lab exams, but I won't do all 5 questions because we know it burns up this much time. But what I will do is I'll do the first 3 again because, well, those are the more sort of, I hate to call it sensible ones. And there's also no guarantee they're always sensible, but those ones should be a little bit easier. We'll do that. Then what I will do is I will hit the AI prompt to see what type of crazy thing it gives me, and then we'll try to solve that one as well. Okay? All right, so again, most important thing isn't the answers. It was the process for getting there. And that is that's how you end up dealing with this course. You can't memorize the answer, but you noticed I use an awful lot of stuff that we've seen a whole pile of times where I've said there's a pattern. Yeah, and these are the things that we try to cover in the course. All right, so that's it for the day, and I'll see you next class.